Hello chemistry fans, and welcome your faces back to Chemistry 1032 problem solving session. I am your host, Dr. Russell Betts, here at the Academic Success Center on Broward College North Campus. I would like to cut this video now. Try again. Chapter 9, Problem 1. Hello chemistry fans, and welcome back to Chemistry 1032 problem solving session here at the Academic Success Center on Broward College North Campus. I am your host, Dr. Russell Betts, and I'm here to guide you through this problem. So without any further ado, let's jump into it. Classify the following as strong electrolyte, weak electrolyte, or a non-electrolyte. All right, let's take a closer look here. All right, so we have some KCl, let's look at a little bit of sugar, some acetic acid. All right, so let's try. First of all, you have to understand what an electrolyte is. An electrolyte is a material that dissolves in water and gives you ions in solution. So ions are things like positive or negatively charged atoms or groups of atoms, polyatomics. So you must dissolve in water and you have to give ions. So let's take a look at the first question. We have potassium chloride as a solid. The S right there means it's a solid. We're going to throw it into some water, and notice the arrow points to the right and there is no arrow pointing back to the left. So this tells me this is an electrolyte, first of all, because it dissolved in water, gave me potassium ion and chloride ion. The AQ, right here, the little little subscript, means aqueous, or dissolved in water. So, and the arrow means that this material completely reacts or dissolves in water to give me K plus and Cl minus. There is no arrow back to the left. So in this solution, I have a whole bunch of K plus ions, a whole bunch of Cl minus ions, but not many of the parent molecule, or not any, excuse me, of the parent molecule. The parent molecule, the KCl, is completely what they call dissociated, which means the cation and the anion have separated in the presence of water. So this is a strong electrolyte. Strong electrolyte. Again, because the parent molecule dissolved in water and gave me complete dissociation, all the molecules fell apart to give me K plus and Cl minus. All right, the next one. So here we have C6H12O6, it's a sugar. S stands for solid. It dissolves in water. Complete arrow to the right to give me C6H12O6 aqueous. Well, the aqueous means dissolved in water. It's just simply dissolved in water. So what does this mean? This means that the sugar, solid, upon addition of water, dissolved, but notice there's no cations or anions. It's just dissolved. So there's two criteria you have to satisfy to be an electrolyte. First, you must dissolve in water. Second, you must create ions. Well, there's no ions here. So this is a non-electrolyte. A non-electrolyte. All right, this leads us to the last question. Here we have a parent molecule. This is acetic acid. That 3 should be subscripted. Plus water, so this is going to dissolve in water. Now look at this little funny thing going on right here, these arrows. We have a half arrow going to the right and a half arrow going to the left. This means equilibrium. We'll get into equilibrium a little bit more later. But basically what's happening is this reaction is going forward and it's going backward at the same time, at the same rate. So as you make products, the products are actually going back to making the reactants. So what's happening in the water is you have a whole lot of your parent molecule. You have very little H plus and CH3COO minus. You have very little, but they are there. So you have a whole bunch of this in water, a little bit of this, and a little bit of that. That's enough to make this an electrolyte. This is an electrolyte. But because of this arrow telling me that the reaction goes forward and backwards, this is not a strong electrolyte. This is a weak electrolyte. Now, if that arrow had simply gone all the way to the right, it would have been a strong electrolyte, but it doesn't. It goes back and forth. That arrow really does give it away. So if you form ions in solution and the arrow points in one direction, it's a strong electrolyte. If you don't form ions in solution, doesn't matter what way the arrow points, if you don't form ions in solution, you are a non-electrolyte as long as you dissolve in water. Here we have a weak electrolyte because we have a parent molecule, dissolves in water, gives us ions, but these ions now react backwards to give us our reactants, our starting material. So this is a weak electrolyte. You have a whole lot of the parent molecule, very few ions. Weak electrolyte. All right? Now, if you still don't understand the difference between a strong and a weak electrolyte or a non-electrolyte, please contact one of the tutors here at the Academic Success Center so you can get help from them, or come on by your professor's office hours during normal time and get help from them. And with that, I'd like to wish you good luck and good chemistry.